We will talk about some differential operator identities. So here is the first one. Show that divergence of the gradient of a scalar field phi is equal to del square phi, where del square is partial derivative with respect to x squared plus second partial derivative with respect to y plus second partial derivative with respect to z. This is called the Laplacian operator. So let's take a look at divergence of the gradient using subscript summation notation. So we have the del operator dot product with the gradient operator. So here's our scalar field phi. And that means we're taking the ith component of each of these vectors. So the first one is the del operator, del xi, partial derivative with respect to xi in ei hat direction, dot product with del xj ej hat acting on our scalar field phi. Okay. Now what is ei hat dot product with ej hat? That is Kronecker delta ij. So that means this is equal to Kronecker delta ij del xi del xj acting on our scalar field phi. Okay. Now, the Kronecker delta implies that these two indices I and j must be equal. So that means we're looking at the partial derivative with respect to xi, and then again partial derivative with respect to xi acting on our scalar field phi. Okay, so that means we're taking the second derivative with respect to xi. So this is del square del xi square acting on our scalar field phi. Now, since we have del xi, the I index appears twice here. This is a summation. So this implies the divergence of the gradient this is acting on our scalar field phi. This gives us the so-called Laplacian operator del square phi which is, according to subscript summation notation here, the second derivative with respect to x when I is equal to 1, the second derivative with respect to y when I is equal to 2, and second derivative with respect to z when I is equal to 3. So this is acting on our scalar field phi. So that's what we called the Laplacian operator. So del square acting on phi. Okay, so the first differential operator identity is regarding the divergence of the gradient. divergence of the gradient is the Laplacian, which is del square. It's the second derivative with respect to x plus second derivative with respect to y plus second derivative with respect to z. Obviously, this is in Cartesian coordinate system. Okay, so starting with the subscript summation notation for del operator, del xi ei hat, dot product with del xj ej hat, the gradient acting on phi. Ei hat dot ej hat gives us Kronecker delta, therefore these two derivatives have the same index, so this means its second derivative with respect to xi acting on our scalar field phi. Therefore, the divergence of the gradient is actually the Laplacian operator, which is implying a summation del square del x square plus del square del y square plus del square del z square.